Hello everyone, so in this video, let us talk about all the 4 problems from the latest Leetcode weekly contest 342. So let's start. The first problem is pretty much simple. It states that you have to calculate the delayed arrival time. You are given a positive integer arrival time, as you can see, denoting the arrival time of the train in hours, and another positive integer delayed time, which denotes the amount that particular train has been delayed. Okay, so you are given these two values. Return the time when the train will arrive at the station in the format of 24-hour format. So which means that this is the arrival time, this is some delayed time. So obviously the total time at which the train will arrive will be arrival time plus delayed time, because that will be added in the total time at which the train will arrive. But because the 24-hour format, if it exceeds 24, let's say it is arriving at 15 at 15 and it is also delayed by 15, so what you'll do is that you will do a modular with 24, because then it will again start from 0 1 till. So if it exceeds 23 and hits 24, which means that it has now started a new day, which will again start from 0 1 2 3 and so on. Okay, so pretty much simple, nothing much complicated, because the time goes from 1 to 24. Nothing much complicated here as well. So what we'll do is that we will just add both of these values and mod it to 24. Whatever is the answer is the output. So nothing much complicated here itself. It's just a modular arithmetic problem that you will plus both of these values. If it over exceeds a given time period, we will like circle back to the very start, because a new day will start with by doing a mod with 24. Okay, now the next problem. The next problem goes is also pretty much simple. Sum multiples. So you are given a positive integer n. Find the sum of all the integers in the range of 1 till n inclusive, which are divisible by 3, 5 or 7. So you're given some numbers, let's say n equal to 7. So you have to take a range from 1 till 7, all the numbers who are divisible by 3, 5 and 7. You will do a summation of all of these numbers. As you can see, the constraints are pretty much solved. So what you can do is that you can just iterate over all the numbers from 1 till n and just check out what all numbers are following this particular condition and just keep on adding them. Nothing much complicated here itself. It's a easy problem as well. So we can just do a for loop over from 1 till n inclusive, and if the number is mod like 3, if it is divisible by 3, 5 or 7, just increment that number in total sum and just print out a total sum. So nothing much complicated here itself also, so I don't need to actually draw out anything. Okay, from here we'll talk about some good questions. So sliding sub-array beauty. The third problem goes like this, that you are given an integer array nums containing n integers. Find the beauty of each sub-array of size k. So you're given, as you can see, a nums array, and for every sub-array of size k, you have to find out its beauty. Now what's the beauty? The beauty of a sub-array is the xth smallest integer in the sub-array if it is negative or 0 if they are fewer than x negative numbers. So what it eventually means is that you have, let's say, a subarray of size k. Now you have to find out the xth smallest integer, and if that integer is a negative number, then only you have to print it. If it's a positive number, or let's say 0, you have to print 0. Okay, so if it is fewer than, so let's say let's take an example that I have some negative number like this, -3, -2, -1, 0, or let's say, just don't put -1, let's put 1 and 3. Okay, so the first negative, like the smallest negative number is, or the smallest number in this subarray. If I want to tell you what is the smallest negative number in this subarray, is this. The second smallest is this. The third smallest is this. So if I actually tell you that in a subarray of size k, which is let's say equal to 4, find out the third smallest number. The third smallest number is 1, which is I do not want, because I just want only the negative numbers if it exists. If I want the second smallest number, the second smallest number is this, and so I can print out -2. But if I just ask you the third smallest number, then it is 1. So instead of printing out 1, I will print out 0. Okay, that is a pretty much simple idea. Return all the like for all the subarrays n minus k plus 1, all these like subarrays are total. You will just print out these values, and that's a complete problem. Now what you can see here is, let's always take a look at the constraints as well. So what you can see here is that n is pretty large, but one of the parameters is pretty much small, that is like ni, which means that the number of values in the array is pretty much small, like only 100 values from -50 or 50. Okay, now what you can do is that you have to find out the xth smallest number in a subarray. So let's say I can do For all the subarrays, I have to find out somewhat the smallest numbers, like any except smallest number, but I have to find it for every subarray. So in that scenario, I will use a sliding window technique for a window of size k, because that will become very simple. Let's take an example of this only. Let's say I have these numbers like this: 1, -1, -3, -2, and 3. So I have to have a window of size 3. So what you can do is, let's take another pen. Let's say I will take a window of size, let's say 3, like this. Okay. Now what eventually will happen is that I will some sort have to find out the minimum of all of them. Let's say the second minimum. Now, how can you find out the second minimum if you do not actually sort them out? Now, if I sort them out, the window every time, it will become very heavy time complexity problem. But instead of that, what we can do is, I already know that these values in the let's say in the array are pretty much small in size, not the length, but its values. The values are pretty much small. So what you can do is that I can put this inside some sort of a map to keep a track of how many numbers are there inside a particular window of size k. So let's say when I move to the next window or to the next side, let's say I move from this point to this point. When I slide my window to this window from here to here, now what we'll do is I will remove this number from the map and eventually add this number to the map, so that the map always contains all the numbers of a particular window, so that I can slide this window from left to right. Now what your eventual task is, that somehow in the map find out the kth or like sorry the xth smallest number. Now all these numbers are there in the map, and the map will always also store them in an increasing order by their key value. So you can iterate over all these key value pairs inside the map and keep on adding it until I reach the xth smallest number. Okay, so let's say the key value pairs inside the map is, let's say there is -1 two times happening in this subarray. There is, let's say, 1 happening 5 times in this subarray. 2 is happening, let's say, 3 times in this subarray, and so on. Let's say I just want the second smallest number. So this is the key value pair. So this is, let's say, key is actually the value, and the value itself is the occurrence of this key inside this subarray. So what you can see is that if I have to find out the second, because -1 is occurring 2 times, which means that obviously in the sorted form -1 will be the very smallest, and I just want that it's the second smallest. The second smallest will be -1, which is obviously our answer. But if I want, let's say I want the fourth smallest number will be this, because this is 2, and then the number 1 is occurring 5 times, which means that it has occurred 2 times. So 3 and 4 times, the fourth time will be 1 is occurring, and 1 is positive number, so I will put 0 instead of that. I hope you understand what I'm trying to say. So this map is actually used to store the complete state of the sliding window, which is of size k, and from that the keys are sorted. So I can directly just keep on adding the values from the top to bottom, because the map is of very small size, given the fact that the keys are only 100 only. So I can just iterate over this map and keep on adding this value until the the xth smallest number I will find out. Pretty much simple. I will move down to the code part to even make it more clear. So what I have done is that this is the answer vector, and I have first inserted the first k minus 1 elements inside the map. This is the map itself. Now, and this is the answer that will store all the answers. Now what I'll do is that I will start from the first kth element and till the very last. Okay, keep on appending that element inside the map. After appending inside the map, I have to iterate over this map. As you can see, I'm just doing a for loop over this map, over all the keys, top to bottom, from in an ascending order, to find out the one which is the xth smallest number. So I will keep on appending, that is y dot second is the value I have told you, the frequency in the total variable. Whenever this total becomes greater than or equal to x, which means that I have now found out the xth smallest number, I will take that particular number, that is num, and break out at this point, which means that I have the number that is the xth smallest number inside the map. Now we have this number. So what I'll do is I will push that number inside the answer vector that I just want to print. Okay, if its number is negative, I will print out a negative number. If it is let's say positive or 0, I will print out 0. So I can do the minimum of both of them, because I will take the negative number or 0 and just push it inside the answer vector. Now this maps contain the particular state. So I've added, I have shifted this particular, let's say, window from left to right. If I've shifted, let's say I have these numbers and I have taken the first 3 numbers. Okay, now I have to shift this from here to, let's say, here. So I have to add this number inside the map, as well as delete this number from the map. So if I want to add this, let's say rightmost, I will add it here. But if I want to remove it from the map, I have to check it that if this key value pair let's say this number is, let's say 5, and 5 has only occurred one time in the key value pair. So I have to remove it completely from the key value pair from the map itself, so that I will not keep on adding it when I'm doing a iteration over the map. So if this particular value that I'm removing, that is I minus k plus 1, that is this total length is k, so I minus k plus 1 is the total, like if I'm adding this value, I will be removing this value. So if this is the index of the value that I'm removing. If it's equal to 1, if its frequency equal to 1, which means that it has only occurred one time, and when I'm removing it, I will completely erase that key value pair from the map itself. But if it is not one frequency, I will just remove that frequency by one, which means that, let's say 5 has occurred for 2 times, and I'm now removing one time from the map. So now only one time 5 is removing. So I will remove its frequency from the map itself, because the map is storing out key value pair, which is the key is the value, and the value is the actual frequency of the element that is occurring inside the complete window. Okay, that's the complete logic for this particular problem. Nothing much complicated here itself. If you still have any doubts, you can push it out in the comment box of this particular video. Okay, so let us move down to the last problem. The last problem is minimum number of operations to make all array elements equal to 1. Okay, so the problem statement goes like this, that you are given a 0 indexed nums consisting of positive integers. As you can see, positive integers are given to you. Now you can do the following operation on the array any number of times. So you can do the following number of operation and number of times. What you will do is that you can take nums of I and nums of I plus 1. You can take any two consecutive numbers and replace their value with the GCD of their value itself. Okay, so whatever two numbers you will take them, find out their greatest common divisor GCD, and replace that number, like either of I or I plus 1, with their GCD. Okay, and you can, and this is one operation. Now you can keep on doing this operation. You have to just find out the minimum number of operation to make all the numbers inside the nums array equal to 1, if it is possible. If it is not possible, print out -1. That is the complete logic. Not logic, actually the complete problem statement. Let's take an example from it itself. What you can see is that this is 2 6 3 4. Okay, let's say if I take these two numbers. Okay, and what I'll do is that I will find out the GCD. The GCD of 3 and 4 is equal to 1, because there is no common divisor. The common divisor is 1. So I can take 1 itself and put it at this particular position, like replace 3 with 1. Now I have 1. So if I take 1 with any other number, it will obviously the common divisor be 1 itself. So I can now spread 1 on both the sides. So I can take a common divisor with 1 and this number. This now 4 will become 1. This and this number, this will become 1. This and this number, it will become 1. So as you can see, now I have taken 4 steps, and in 4 steps I can convert all these numbers to 1. I hope you understand. So one of the observation can be that I just have to find out two consecutive numbers that is equal to 1, their common divisor equal to 1, and I can convert them into 1 and spread it all across. Or one case can be there that let's talk about some few other cases as well. The first case can be that there is already 1 present inside the array. Let's say I have, let's say 2 3 1 and 4. If I already have 1, I've told you, take this 1 and spread this 1 all across the whole array. Let's say I will take a GCD of this and this. What will happen? That the GCD of this and this will eventually be 1, because like the 1 with GCD of anything equal to 1, GCD of 1, like a GCD of two numbers in which one of them is 1 is equivalent to 1 only. So what you can see is that this will turn out to be 1, and I can replace this with 1. Now this is 1. I will again now do a GCD of these two to make this 1. Now this has turned 1, so do a GCD of these two, make this 1. So eventually what I'm trying to do is that I will take out if there is 1 present inside the array. I will not actually have to change them because it is already 1, and I can just traverse like you can say infect or change all the other numbers that are non-1 to 1 easily. So the total number of numbers, let's say in the array is n, and the total number of ones, let's say I have 5 ones, and let's say I have 10 total numbers. So I just have to infect that 1 to other numbers, and they can directly just convert to 1. So how many number of changes or number of steps I will have to do? I will have to 5 steps. Okay, so it's simple that the total number of n minus the total number of ones I have. The total number of ones I have is the total answer if I have some ones in the array. If I don't have any ones, I will try to do some other thing. Okay, now let's say there is this example also, that what eventually happens is that if you take this, you cannot converge down to, let's say, any all the ones. Why? Because let's take an example, understand this, why this is not actually happening. What you can see is that if I take the GCD of these numbers 2 and 10, because 2 is the smaller one, it will still remain 2, and I can only convert it to 2. So then this is 2 and 6, it will again convert to 2. 2 and 14 will again convert to 2. So it means that everyone can converge to 2, and then I cannot do anything. What is the actual problem? The GCD of all of these numbers is actually equal to 2. So I can also now again check that the GCD of all the numbers, if it is equivalent to, let's say, any number greater than equal to 1, then greater than 1, actually greater than 1, then it will not converge to 1, because as you can see that the GCD of them is actually equal to 2, and I cannot take any pairs or anything to converge it to 1. Okay, that is also the case from -1. So I've now considered two cases. If I have some 1, if I have the GCD of all the numbers and equal to, let's say, it is greater than equal to 1, then it is not equal, like the answer will be -1. So these are cases are done. Let's say I don't have anything like any ones inside here, and the GCD is also not satisfying this condition, like the total GCD converts to 1. What's the answer? What you can see here is that I have told you that I can take some pair. Okay, I can take some pair, and like what I can do is that I can like merge them and convert it to 1, but it cannot always happen. Let's take some small example. Let's say I have 10, 15, and let's say 6. Just taking some small example, what you can understand from here itself, that the GCD of these two numbers is equal to 5. GCD of these two numbers is equal to 2. So which means that the GC, if I take these two like pairs itself, what eventually will happen is that if I can take these two values, they will, like the GC, I will replace them with any of them. So let's say this will become 5, and then I will take GCD of both of them, and then it will become 1. I hope you understand the overall idea is that somehow two values is not the always case in which if I take two values, the GCD is always equal to 1. But multiple values, if I take, the sub-array can have a GCD equal to 1. So because now I can like propagate this value throughout this whole array and convert everything to 1. What I'm trying to say is that I have shown you one case that if the GCD of all the numbers equal to 2, or let's say greater than 1, what eventually happens is that whatever sub array I can take, it will not become 1 in any case. But if I have some smaller sub array, let's say this sub array is, let's say, 6, 10, 15. If I take the complete sub array means that I will keep on taking two consecutive pairs and change them. Let's say I will take these two pairs and change this to the smallest GCD. Okay, let's say this is 6 and 10. The GCD of them is 2. So let's say I convert this to 2. Then I will take the GCD of both of them. Then the GCD of both of them is equal to 1. So what it eventually means is that I have n numbers and I have to find out the GCD of n numbers, then that can also converge to 1. So what I can do is that if this value or these two conditions doesn't hold, what you can see here is that the constraints are pretty small, that the total length of the array is only 50. So what you can find out is that you can do a O of n square loop in which find out the smallest sub array whose total GCD of all the numbers is equal to 1. Okay, let's say I find out the total sub-array length equal to 5. Okay, so let's say 5 numbers I have which are used to convert to 1. So let's say I have these numbers. So I will take a GCD of all these one by one, taking a pair. So I will take 4 pairs. So whatever is the total length, let's say total length is n. So minus 1 is the number of operations I have to first do to get to a first one, because I will take these two numbers and take a GCD of them. It will convert to some number. Then I will take another these two numbers, convert it to, and keep on doing it until one will appear in the very last position. Now all these numbers are still not 1. Now whenever I got 1, now I can like spread this or like take GCD of 1 with all the other numbers one by one to convert them. So let's say now if 1 is converted, the total length is, let's say, n. So now n is there, and all the other numbers except this one I have to again convert to 1. So I have to understand the total number of operations will be required is n minus 1 plus n capital N minus 1. This n is the smallest sub-array whose total GCD of all the numbers is equal to 1, and this is the total length of the sub-array, total length of the array itself. And that is the actual logic that you can use to actually solve this particular problem. Okay, let's take a look at the example. Or actually code part. Now what we have done is that we have first taken care of these two conditions, that I have taken a GCD of all the numbers and find a number of ones in there. If the total GCD of all the numbers is greater than 1, which eventually means that no matter what I'll do, the GCD will never converge to let's say 1. In that scenario, the answer is -1. If I have at least some ones in there, what I can do is I can spread them or take that 1 and 2 GCD with all the, let's say, numbers around it, so that all of them will eventually become 1. So the total number of operations I have to do is total number of size of element in the array minus the total number of ones that we have find out in the array. Okay, because ones are already 1, I don't actually have to change them. Total number of elements that are left apart from ones, I have to change them and convert it to 1. Okay, that is n minus 1. And the total, and if both of these conditions doesn't hit, the total answer will actually is that I have to first find out the smallest subarray whose GCD of all the numbers is equal to 1. So what I'll do is that I will iterate over all these, as you can say subarrays, and find out the smallest, let's say array, subarray whose GCD is equal to 1. Whenever I find out 1, I will actually have to minimize the total length of the subarray. So I will just minimize total length of subarray whose length is equal to 1. And the total answer is the smallest length subarray minus 1, because that's the total number of operations required to convert that particular subarray one element equal to 1. The total subarray length is, let's say, 5. So 4 operations are required to convert one element in that particular subarray to 1. Now, after we have got 1 in the complete array, I will now infect all the numbers, or like propagate that one, do GCD of that particular one with all the other numbers one by one to convert it. So because how many elements are left inside the array, I have 1 that is already converted to 1 using this number of operation. So how many elements are left? Total n minus 1 elements are left, which the total number of operations I will do to convert all these other numbers to 1, and that's a total complete answer. Okay, that's a complete logic and the code part for this particular problem. If you still have any doubts, you can mention in the comment box for this particular video. I'll see you in the next Leetcoding, and bye.